Hello chemistry students, this is Mr. Laudermith and I'm here today to show you the first of 3 labs from Unit 2 that'll help us better understand learning target number 4. In this lab, we want to answer the question, what happens to the pressure of a gas when its volume doubles, triples, and is cut in half? For our procedure, we are going to GAM-TRIB. We're going to graphically and mathematically model the relationship between a gas's volume and its pressure. Step number 1, obtain a LabQuest, which if you are unfamiliar with a LabQuest, that is a LabQuest. Basically, it's a small computer that we can connect various sensors and probes to collect data for us when we're taking the lab. I can connect a temperature probe to this. I could connect a pH probe to this. Or, in the case of the lab we're going to do today, I want to hook up this, a gas pressure sensor probe. And it does exactly what its name suggests. It records the gas pressure that it's experiencing at a given moment in time. Now, since we want to see what happens to the pressure when we change the volume, we're going to need a way to change the volume of air that's exposed to that gas pressure sensor. And to do that, we're going to use one of these, a syringe. And I think you can see it does have volume markings on the side. Yeah, those markings are in milliliters. So I can change the volume of a gas, in this case air, that I put into this cylinder. And by changing the volume in the syringe, I can then see what the effect of the pressure is going to be. So step number 2, it says fill the syringe with gas, in this case air, to 10 milliliters. So I'll go ahead and do that. I'm going to pull back on the plunger, like so, until the bottom of the plunger is at 10 milliliters. Like so. Perfect. Step 3 says record pressure and volume at 10 data points between 5 and 20 milliliters. Between 5 and 20 is not a huge range, but we can definitely get 10 data points within that range. Now, before we start doing that, we have a question that we need to answer. Which gas variables are we holding constant in this lab? It's not volume. We just said we need to change the volume so that we get 10 different data points between 5 and 20 milliliters. It's probably not going to be the pressure because we're expecting to see some kind of change in pressure when we change volume. So that really only leaves 2 other possibilities for variables that we're going to need to keep constant. And those 2 variables are going to be temperature. Right now, the room is just at regular room temperature. I don't expect it's going to change over the few minutes it takes to do this lab, so we can treat temperature as a constant. So I'll make a note of that. We want constant temperature. The other one, which might not come to mind right away, we want to keep the same number of gas particles the whole time. We want to make sure that the number of gas particles isn't changing. We are going to change its volume. We're going to change the amount of space those particles exist in. Could be bigger, could be smaller, but the number of particles is going to stay the same. That's why, just a minute ago, I filled up my syringe to 10 milliliters, and I'm not going to put any more air in or take any air out while I'm collecting data in this lab. I'm just going to push on the plunger to change the volume. So we want to keep temperature the same and number of particles. Okay, so what I just did, I connected my syringe, remember that we filled to 10 milliliters, to my gas pressure sensor, so that's all ready to go. And I've decided on the volumes where I want to collect data. I've picked my 10 data points and I filled those into the table. So we'll get the pressure at 5, 6, 7, 9, 11, 13, 15, 17, 19, and 20 milliliters. And to show you how I'm going to get the data, give me a second just to change my screen. What you're seeing right now, this is the actual screen of my LabQuest. It's showing you the pressure in the units millimeters of mercury, mmHg, and I can now go ahead and change the volume on my syringe to whatever I want, and I can note what the pressure is right here on the screen. So for instance, my first data point was 5 milliliters, so I'm going to go ahead and push in on the plunger of the syringe until it reaches 5 milliliters. There it is. And you got to kind of hold it steady. And it's reading right about 1,300 and kind of hard to hold steady sometimes. We'll call it 1,370. We don't have to be totally precise, especially with that number after the decimal point. That's not going to be a precise figure. So let me go back to my data table. And at 5 milliliters, we'll say that we had a pressure of 1,370 mmHg. Okay. Let me now adjust my syringe again. This time I want to set it to 6 milliliters. That was my next data point. And I'm right at 6, and we're right at about 1,150. So I'm going to go back to my data table. 1,150. Now I can do 7. That's about right. So I'm right at about 1,030. Okay. And I can keep going with this. I'm going to jump ahead for a second. We've done some of the smaller volumes. Let me try one of the bigger volumes. So for instance, let me adjust my plunger now to 15 milliliters. This time to get to 15, I don't push in. I'm going to have to pull out. So if I pull it out to 15 and I hold it, let's go to screen there. Right at 15, right at about 505. Okay. Thanks to the magic of screencasting, in just a second you're going to see the rest of this data table filled in, because I'm going to take a couple minutes and get that data right now. All right, did you miss me? So here we have the rest of the data. I just followed the same procedure I was using before. I adjusted the syringe to the different volumes and wrote down what the pressure was on the LabQuest. So you can see I filled in the data table. Now, we're going to have you make your own graph and do some things with this data, but I decided just for fun to go ahead and make my own quick graph, and I'd like to show you that. So if I could, there it is. So right away, I think we can see something kind of interesting. As the volume of the gas increased, as we went from 5 to 20, its pressure decreased. It went from over 1,300 mmHg down to less than 400. So there seems to be a very clear relationship at work here. And maybe we should make a note of that back below our data table before we call an end to this lab. We have looked at the relationship here, and we can, I think, pretty conclusively say that as the volume of a gas increases, its pressure decreases. We got to add a little extra to that though. As the volume increases, the pressure decreases when, remember, we have to keep temperature and number of particles the same. If we hold those two variables the same, then this relationship will work. All right, I'll see you next time. Bye.